Here we are looking at some graphs. They appear to be sinusoidal. See how they're just wiggling up and down, cycle after cycle. Okay, so they have the feel of being a sinusoidal curve. We suspect that probably they're one of these kinds of curves. In other words, at this particular moment, we're interested in doing this problem, if I can get it to come. Given a graph, we want to produce the equation that goes with that particular graph. All right, so let's see what we can do on this first one. This first one, should I choose it to be a sine kind of thing or a cosine sort of thing? Either one we can work with, but in this one I'm tempted to call this a cosine because it starts high and then there's one cycle right there, starting high and then ending high and again and again and again. So I'm thinking it's going to be this kind of a situation. Next, it should be centered on the x-axis. It looks like it's been lifted up somewhat. Notice that it's going between 0 and 1, so the middle part here is at 1/2. It appears to be lifted up by 1/2. So that's the first guess that I'm going to make here, is that the d value, because d says how it's been lifted up or pushed down, is going to be 1/2. The second thing that I'm going to observe is that because it's going between 0 and 1, if this was at 1/2, then the amplitude is going to be 1/2. So the a is going to be 1/2. So there's my first two guesses on this particular function. So the cosine, now I need to figure out what the b and the c are. Now here's what I'm recommending that you do there. You decide where you think it's going to start. We decided that this was going to be a cosine and that the start of the first cycle is going to be when x is 0. So when x is 0, I've got b times 0 plus c, and that needs to be the start of the first cycle for the cosine, and the cosine starts at 0 because I've got that memorized. So solving that equation, we discover that c would need to be equal to 0 if we're going to match it to this sinusoidal cosine thing. Secondly, I worry about where one cycle is. It starts here, comes over here, and then ends right here. That's over at 2, 4, halfway would be 3, a little more than 3. That's making me think that maybe that's at pi, and in fact 1, 2, a little more than 6 is 2 cycles, so one cycle would be at pi. So the end of the first cycle is going to be at pi, so b times pi plus c, and we decided that c was already 0, needs to be equal to 2 pi. Okay? So the trick here is to look at this argument on the inside and decide where we think the cycle is starting and where we think the cycle is ending. It needs to start when x is 0 and the cosine cycle starts at 0. So we needed to set that equal to 0. We think that this cycle ends when x is pi. So when x is pi, this bx plus c needs to be equal to 2 pi because that's the end of the cycle for a cosine. So solving that equation, notice that b is going to have to be equal to 2 to make that true. Okay, so there we are. We think that we've got the equation of this curve. Y is equal to 1/2. Well, let me just write it in up here. B we decided was 2, and C was going to be 0, so it's silly to write in that plus 0, but I'll do it just for completeness. Okay, so here I'm pulling in a graphing utility. I'm going to worry about graphing y is equal to 1/2 cosine 2x plus 0, of course, plus 1/2. And so that's going to look at that particular graph and just ask it to do that, and we'll see. Okay, and notice how close that comes to the shape that we've got here. Everything is happening where it's supposed to be between 0 and 1, then wiggles out again and made 2 cycles, a little bigger than 6. So that seems like a pretty reasonable solution in that particular case.